Welcome back to the GCSE Maths Pro YouTube channel. Today's video is the first part of vectors, where we'll be looking at column vectors specifically. So the first bit is to understand how a column vector is laid out and how it works. So you can see an example here. We're told that A is the vector minus 2, 3. So we've got a number at the top and a number at the bottom in brackets, creating this column. The top number means how far we're going to move left or right. If it's a negative, we're going to move left. If it's a positive, we're going to move right. The bottom number is therefore up or down. This one's pretty self-explanatory, so obviously if it's positive, you're going to go up. If it's negative, you're going to go down. Column vectors can be drawn as actual vectors on a grid. They don't have a position in terms of coordinates. There's no actual position. You can draw it anywhere that you have space on a grid, but you just have to make sure the number of squares left and right and up and down are correct. So for this vector A, we've got minus 2 at the top. That means I'm going to move 2 to the left. And then it's 3 positive at the bottom, so up by 3. Then we just connect these 2 points together with a diagonal line. So that's the basis of how column vectors work. So our first question here is to draw the column vectors on the grid. So again, as I said, there's no location as such, there's no coordinates. You can draw them anywhere on the grid as long as you obviously have space for both. So looking at A, we've got 4 at the top, which is positive, so that means 4 to the right. So let's say we start here, 1, 2, 3, 4 to the right. And then minus 1 at the bottom means down by 1. So can you see how I'm going to join up these 2 points here? So there's my column vector. I'm going to draw with an arrow the direction it's moving so that I know that it is to the right and then down. And then label it with the letter A so we know which one it is. Then obviously you can rub out the other parts that you've worked out. And then I'll do the same for B. So B, we've got minus 5 at the top. So that means I'm going to be going 5, but to the left. So let's start here. 5 to the left, 1, 2, 3, 4, 5, roughly there. And then we've got positive 2 at the bottom, so that means up by 2 here. And then I again join it up. Now again, draw an arrow. This one was going, as you can see, to the left and then up, so we're going to be drawing the arrow this way, and we can label that B. So there we have it, we have our 2 vectors. Now we know how to draw column vectors as actual vectors on a grid, we have a slightly more complicated question, because part A here says, write 3A as a column vector. We're given just A as 3, 1, but you see how now they want 3A. So literally just think of it as you would with any kind of algebra. What does 3A normally mean? Well, it means 3 times A, 3 lots of A. So literally all that's saying is, if this is A, that's like 1A, isn't it? I just want 3 of those. So I need to it's like a scale, isn't it? I want it 3 times as big. So to write it as a column vector, literally all I need to do for 3A is multiply both numbers, the top and the bottom, by 3. Okay, because it's getting 3 times as tall if you imagine it vertically, and 3 times as wide if you imagine it horizontally. So 3 times 3 at the top is now 9 along to the right. 3 times 1 at the bottom is 3 up. So it's literally just the same exact vector. It's now 3 times as big. Part B is to then draw the vector 3A on the grid. Well, now we know the numbers, I can just literally straight away draw it. So 9 to the right and 3 up. Again, doesn't matter where you put it on the grid as long as you've just drawn it somewhere where you've got enough space. And then make sure you draw the arrows so that we know which direction it's going in. Because for vectors, it's also important which direction. Because, yeah, the 9 and 3 are correct here, but is it going 9 to the right and 3 up, so it's going this direction? Or the other way would be actually 9 to the left and 3 down. That would be a completely different column vector, wouldn't it? That would be written as minus 9, minus 3. So it's the same line, but do you see how if you draw the arrow the wrong way, then it's not accurate? So our arrow has to be going upwards because we were going up by 3. So that is 3A. Now, if I just quickly draw, that's the answer to that question, but if I just quickly draw an example of just A, so you can see what we mean, I'm just going to draw it just above. A originally was 3 to the right and 1 up. That was A, wasn't it? And again, the arrow was in the exact same direction, A. So you can see how these are parallel. It's just one is 3 times as big as the other. That's the only difference. Okay, this is a similar one. Now we've got 2 vectors. We've got vector A, which is 5, 7, and we've got vector B, which is minus 3, minus 1. Part A says write A plus B as a column vector. So the same as before, we did 3A, we timesed it by 3. In this case, we're just adding both of these together. So I've got the 5, 7 for vector A plus minus 3 minus 1 for vector B. Just be careful of the negatives. I'm literally just going to add across. So what I mean by that is the top two numbers will add and then the bottom two numbers will add, right? Because the top two are left and right, so they go together, and the bottom two numbers are up and down, so they go together. So just add as you normally would with these negative numbers. So 5 plus minus 3 is obviously going to be 2. And then 7 plus minus 1 is going to be 6. So our new vector, or the vector A plus B, is 2, 6. Now it says to draw vector A plus B on the grid. Obviously, because I've already worked this out, I can literally just go straight into drawing 2 to the right and 6 up. So there's our line. Because it's going upwards, I'm going to draw the arrow this way round. So that's our vector A plus B. Now, just a little bit of explanation. If you hadn't worked this out, let's say this wasn't the part A, let's just say it said draw vector A plus B straight away on the grid. You could draw vector A first. So if I do it in a different colour, vector A is 5 to the right and 7 up. So let's say if I start from the same place here, that's vector A, isn't it? We've got 5 across to the right and then 7 up. So that is vector A on its own. And then B, because we're adding them, let's say they connect. So I'm going to start from the top of A. B is then minus 3. So that means 3 to the left and minus 1 down. So that would put vector B there if I were to do it, stuck onto the end of vector A if they were together like that. Do you see how, therefore, the pink one is A plus B? From the start of A to the end of B, that's vector A plus B. Okay, so that hopefully is a visual representation of what happens when we add them and why it works, that we can just literally add them together. Because you can see we went 5 to the right, but then we went back 3 to the left. So we ended up with just a difference of 2. And then we went 7 up and then down by 1 again, so the difference was 6. Okay, so for this one, we've got another pair of vectors A and B. A is minus 1, minus 5, and B is 3, minus 4. So part A is to write A minus 2B as a column vector. So this one's actually combining those past few questions together. We've got a subtract, we've also got a multiple. So for this one, I would normally write out A just because it's still itself, isn't it? Just 1A. Subtract, and then I would work out 2B, so 2 times both numbers in B. So 2 times 3 at the top is obviously 6, and then 2 times minus 4 is minus 8 at the bottom. Now I can go ahead and subtract. Again, with the same with adding, we're going to subtract the top 2 numbers and then the bottom 2, and just deal with any negatives as you normally would deal with negative numbers. So at the top we've got minus 1 take away 6, so that's going to be minus 7. And then at the bottom we've got minus 5 take away minus 8. So here we've got a double negative with the take away minus 8 part. So it's actually minus 5 plus 8 effectively, isn't it? So that would be positive 3. So we've got minus 7, 3 for part A. Then as you can see, part B is to draw the vector A minus 2B on the grid. So drawing the minus 7, 3 on the grid. So minus 7 means we're going to the left by 7, and then 3 means we're going up by 3. So that's our line. It's obviously important to point the arrow in the correct direction. Because we're going up and we're going left, we're going to be pointing the arrow this way, aren't we? So that is A minus 2B as a vector. So that's our answer to part B. Okay, the other way that we could get a question is maybe they draw the vector for us and they ask us to work backwards and write it as a column vector. So let's do A first. Literally, as we know, we've got a top number which is left or right and a bottom number which is up or down. So first of all, how many are we going left or right? Because of the arrow, I can see that I'm going to go this way. So that is 3 to the right, so that's positive 3 at the top. But then I'm having to go down by 1, 2, 3, 4, 5, 6. Because we're going down, obviously it's a minus 6. So that's vector A. We do the same for B. I'm going to start here and obviously follow the arrow in the direction. Normally I go left or right first because that's the number that's at the top. So you can see we're going right by 3. So that's a positive 3 again. And then this time we're going up by 2. So it's positive 2 as well. Okay, so those are the column vectors for A and B. Okay, so our final question, this is a slightly more advanced question, so maybe more so for higher tier. They've given us vector A as 9 minus 2. However, do you see then they've given us the vector for minus 4a plus 3b, which is 9 over minus 4, and they've asked us to find b as a column vector. So we've kind of got this calculation, like the answer to the calculation, we've got one of the starting vectors, we just don't have the other. So this one we're going to have to work backwards a little bit. Because we know what a is, I think it's probably easier to start by working out what is minus 4a. So minus 4 times by a. Because we're multiplying, we're obviously going to change both numbers and just use your negatives, multiplying negatives as you normally would. So we've got minus 4 times by positive 9, so that's obviously going to be negative 36. Then we've got minus 4 times by minus 2, which is positive 8. We've got a double negative there, so just be careful. So that's minus 4a, isn't it? Okay, so let's write that in our equation. So we've got minus 36 over 8 there, plus 3b equals 9 over minus 4. The only thing that's missing is b. Now, obviously, b is going to be two different numbers, isn't it? A column vector has a top number and a bottom number. So it's up to you how you want to go from here. I tend to like to use algebra. So I'm just going to bring in 2 letters for each of our numbers that are missing. Obviously, we've got 3 here because we're going to multiply whatever b is by 3. Let's call the top number x and the bottom number y because we know that we need one for left and right and one for up and down. See how now I can just take across x and y separately? Because obviously the top numbers are all to do with left and right, so they can go together. And the bottom numbers are all to do with up and down, so they're separate, they go with each other. So for example, don't forget this 3 here. For the x one, we've got minus 36 plus 3 times x, which is obviously 3x, is equal to 9. Okay, do you see how I've picked that out from the equation? So I'm just going to solve this first, then we'll look at the y. So this is just a normal equation now, so I want to get x on its own. I'm going to add 36 to get all the numbers together, so that gives me 45. Then I just need to divide by 3, so that gives me 15. Okay, so x being the top number, that means that it's 15. And then let's do the same, but for the bottom numbers. So we've got 8 plus 3y this time is minus 4. And now let's just solve this for y. So obviously take away the 8 to move it across, so we get minus 12. 3y is minus 12. Divide by 3 again is minus 4. My column vector b is therefore 15 at the top and minus 4 at the bottom. That's how I would solve this question. So thanks for watching this video. That is everything on column vectors. If you are doing higher tier, make sure to check out the next 2 videos which are on vectors geometry. That's where we're looking at more shapes rather than actual numbers. Otherwise, make sure to like and subscribe and leave down below any questions or comments that you might have.